So the next part of discussion here in this chapter is manufacture of NaOH from NaCl aqueous solution. Here the common say is whenever you say NaOH, it is sodium hydroxide. It's a strong base, sodium hydroxide. It's a strong base, but this sodium hydroxide is also called caustic. It is also called caustic soda. Sodium hydroxide is also called caustic soda. Similarly, if you go for NaCl, it is sodium chloride. It is sodium chloride. It is a strong base. It's a salt. It's a salt of strong bases and strong base. It is a salt, and likewise this sodium chloride, it is also called brine solution. Also called brine solution. So here what is happening here is we are trying to manufacture the sodium hydroxide from aqueous brine solution. So this brine solution, sodium chloride aqueous, when it is subjected to electrolysis, when sodium chloride is subjected to electrolysis in the form of brine solution subjected to electrolysis involves reduction as well as oxidation. So here you find that actually this Na plus sodium chloride brine solution, it gives away two ions, Na plus aqueous plus Cl minus ion of aqueous. Na plus is cation, all cations is deposits at cathode, and all anions, Cl minus ion is an anion, so all anions deposits at anode. So here at anode always oxidation process occurs, and at cathode always reduction process occurs. So here reaction, we can take reaction at anode. If you take, that is nothing but oxidation, if you take, that is there are two Cl minus ions, so two Cl minus ions, one Cl minus ion is there, chloride ion, take that chloride ion, it gets oxidized, aqueous, it gives half mole of chlorine gas with the loss of one electron. This is oxidation. Because the electron is lost, it is de-electronation. It is also called de-electronation oxidation. Go for reaction at cathode. Reaction at cathode. Here, if you take this Na plus ion will not participate in the reaction because it has low potential in the reactivity series. Na plus ion in the reactivity series, its electrode potential is less than hydrogen electrode potential. Because of that, it cannot directly involve in the reduction process Na plus ion. That's why you can take water as a solvent, because Na plus ion brine solution aqueous means water is a solvent, less of salt, more of water. So water molecules, two molecules of water, when they gain electron, liquid, it gives two OH minus ions, hydroxy minus ions, and H2 gas is liberated. These two OH minus ions, now they interact with the two OH minus ions, now they interact with the Na plus ions at the same cathode. So 2 moles of sodium ions aqueous plus 2 moles of OH minus ion gives rise to, that is 2 moles of NaOH aqueous or NaOH solid. So therefore, coming to conclusion, here we can come to the conclusion, therefore from the electrolysis of aqueous brine, the products obtained are at anode we got H2 gas, and at cathode we got, that is at anode we got Cl2 gas, this is at anode we got Cl2 gas, and at cathode we got H2 gas and NaOH. Caustic soda is also produced. So it is very clearly understood that by the time the electrolysis of aqueous brine is completed, at anode we are getting chlorine gas as the main product, and at cathode we got one gaseous product and we also got one solid product. But the purpose of doing the electrolysis of the aqueous brine is solved, because our main purpose of this topic is to manufacture NaOH, that is NaOH is caustic soda. So this caustic soda obtained at cathode and hydrogen gas obtained at cathode and the chlorine gas obtained at anode, they have certain commercial applications, commercial significance, and they are used for various purposes in our daily chemistry, usage in our daily life. Therefore, the flowchart method of understanding the electrolysis of aqueous brine for the manufacture of sodium hydroxide. Actually, what we are doing here is we are taking NaCl, aqueous, that is brine, and through the process of electrolysis, we are able to get here, three important products. One is we are getting chlorine gas is obtained at anode and hydrogen gas and NaOH solid is obtained at cathode. Here these two products are obtained at cathode electrode. And this product is obtained at anode electrode. So therefore this electrolysis method sometimes is also called as chlor-alkali method. Why it is called chlor-alkali method? Because at anode we are able to obtain chlorine, that's why chlor. At cathode we are able to obtain a base, alkaline base. Bases are alkaline in nature, that's why alkali. Base is obtained at cathode, so alkali. Chlorine is obtained at anode, so therefore chlor-alkali method. What are the important applications of this chlorine? Chlorine, it is used as a bleaching agent. So here if we take this chlorine, it also has some more applications, like this chlorine, it is also used in polymer industry in the form of PVC. What is PVC? PVC is nothing but polyvinyl chloride. So in polymer industry, polyvinyl chloride, it's a kind of plastic. Then if you go for hydrogen, this hydrogen is a basic ingredient in the fuel cell. If you take fuel cells, we use two gases, one is hydrogen gas and the other one is oxygen gas. This H2 is a important gaseous fuel for fuel cell. Then the same hydrogen, it is also used in manufacture of ammonia through Haber's process. It is also used in conversion of oils to fats, and it is also used for producing water vapor in the space astronauts during space exploration. So sodium hydroxide has various types of applications, that is NaOH. It is used in the manufacture of soap, in the manufacture of detergents, in the manufacture of papers, in paper industry, and fibers, artificial fibers. Here if you take that is this NaOH, if it is coming in contact with chlorine, also there is one more chance. When sodium hydroxide comes in contact with chlorine, then you find that a kind of disproportionation reaction takes place. And it gives out, that is sodium chloride plus sodium hypochlorite. This sodium hypochlorite is obtained, which is used as a bleaching agent. Similarly, the same chlorine which is obtained, if it is separately added with the calcium hydroxide, and if it is treated with chlorine, you get CaOCl2 plus H2O, which we call this as bleaching powder. The Formula of the bleaching powder is CaO, Cl2, calcium oxychloride.